Welcome to Study Loop.
Let's go ahead and find the partial fraction decomposition for these fractions given in part A and B. So let's start with part A, x to the 6th on top, x squared minus 4 on bottom. The first thing to always check for this type of problem, which by this problem I mean polynomial divided by polynomial, we always want to know if the numerator has a degree greater than or equal to the denominator. If it does, we should use long division. Here, numerator has degree 6, denominator has degree 2, so we go for the long division. So let's go to the right and do this. We have x to the 4th over here, and then that'll give us x to the 6th minus 4x to the 4th power. Go ahead and subtract. And then up here we get a 4x squared minus 16x squared. Subtract that, we get 16x squared, and then that'll give us a plus 16 up here. So that'll give us 16x squared minus 64. So subtract that, and we're left over with 64. So that's our remainder. So part A, we can rewrite this. Long division gave us a quotient of x to the 4th, 4x squared plus 16. Then we have our remainder. And then we have the original denominator, x squared minus 4. And now we just go ahead and use partial fractions on this only remaining fraction over here. And now no more long division will be needed because the denominator has bigger degree. So we should take this denominator and go ahead and write that as x minus 2. Always want to check if we can factor these. And then we have two distinct linear factors. So this will be what the book calls case 1. So we'll use the formula for case 1 to rewrite the fraction. And this will become, we have a over x minus 2, and then another constant b over x plus 2. And that'll be our answer for part A. Let's go on to the next page for part B. So let me rewrite that down for part B. We have x to the 4. All over, and then we have x squared minus x plus 1, x squared plus 2 squared. So we will not need long division here because the numerator has degree 4, whereas denominator, it will have degree 6. So this will be degree 4 when you square it, and then adding 2 more x's from this leading term will give you x to the 6th. So no long division. So now we're ready to go straight to the partial fraction decomposition. But since these are quadratics, in the parentheses, we have to check if they factor. So let's look at x squared plus 2. So if a polynomial looks like this, ax squared plus bx plus c, we need to look at b squared minus 4ac. If this is less than 0, then does not factor. The quadratic does not factor. So for this polynomial, x squared plus 2, we have a equals 1, b equals 0, c equals 2, and we see that b squared minus 4ac will just be 0 minus 4 times 1 times 2. So minus 8, which is less than 0. So this will not factor. So that's a quadratic that doesn't factor. And then we could also look at this other quadratic over here. So this one, Let me erase that. We have x squared minus x plus 1. So for this one, we see a equals 1, b is minus 1, c is 1. So b squared minus 4ac. We have 1 minus 4 times 1 times 1. So we have minus 3, which is also negative. So that means that this other quadratic on the bottom left also doesn't factor. So this will be what the book calls case 3. We have distinct quadratic factors that are irreducible, that cannot be factored into smaller parts. So this we can write as ax plus b over x squared minus x plus 1. So that's for case 3. And in this term, actually we'll be using case 4 for the second term because this one's to the second power. So for this one, because it's a quadratic on the inside, we'll have a cx plus d over x squared plus 2. But since it's a repeated factor, we'll have to do this once more. But this time, on the x squared plus 2, we'll have to square the very last one. And that'll be our partial fraction decomposition for part B.